So critical numbers. Critical numbers are those numbers that make the derivative of a function equal to 0 or otherwise undefined. And also these numbers have to be in the domain of f of x, which is basically our starting function. And then, okay, so this is what I'm going to teach you guys in this video, the critical numbers. So, how about, sorry about that, I'm kind of sick. So, let's try one, shall we? So, I'm going to give you two options to, like, which one to do first. So, here they are. The x squared over x squared minus 9. It's probably going to be the easiest one, considering the other one has the square root. So yeah, let's just pick that one. Okay, so x squared over x squared minus 9. Pretty simple. And then so first let's use the quotient rule, which basically makes us use the bottom times the derivative of the top minus the top minus times the derivative of the bottom all over the bottom square. And then let's just simplify that to 2x cubed minus 18x minus 2x cubed over the bottom square. See, we have 2x cubes, so let's just like get rid of those. So we're ended up with negative 18x over the bottom square. So let's just find the zeros from that. So basically, to get the zeros, we have to make the top equal to 0. This means just basically set 0 equal to negative 18x. And then, so once we've done that, you can basically just tell from there that x will be equal to 0, because negative 18x with x is equal to 0, it will just give you 0. So it's pretty simple. So let's find the undefined numbers, which is basically putting the bottom equals 0. So we'll just put 0 equal to x squared minus 9, all of that squared. So we can pretty much tell that it's either going to be positive or negative 3, considering that 1 squared will be equal to 9. So it will be 9 minus 9 squared, which is equal to 0. So see, it's pretty simple. Not really much trouble. So let's try another one, shall we? Yeah, let's try the square root one, even though it's a bit annoying at times. So yeah, let's try it. Okay, so x square root of 16 minus x squared. So first let's rewrite this function, which basically by rewriting we're just going to make it easy for ourselves to like find the derivatives later on. So let's just name it g of x, and it will be equal to x 16 minus x squared, all of that by the power of 1/2, which is equal to square root. So from there, let's use the quotient rule. Yeah, which basically going to makes us do the front one, which is the x times the 16 minus x squared, just normal, plus x 1/2 of 16 minus x squared, all of that times the power of 1/2 minus negative 2x, which is the inside from the 16 minus x squared. So let's just rewrite that. It's basically 16 minus x squared by power of 1/2 minus x squared, 16 minus x squared minus, times the power of negative 1/2. You see, we have basically the same thing with the 16 minus x squared, so let's just get rid of those. So we'll just take it outside, and now we'll have 16 minus x squared, we'll have by the power of 1/2, and we'll just put a little group thing where it's the 16 minus x squared minus x squared. So we'll just rewrite that as 16 minus 2x squared over 16 minus x squared by power 1/2. So let's find the zeros, which is basically what we did last time. So set 0 equal to 16 minus to x squared. And then from there we can basically take out the 2 since they're both divisible by 2, so let's just put 0 is equal to 8 minus x squared. And then from there, it's pretty simple. I mean, just set the x to make 0. So x will be either this positive square root of 8 or negative square root of 8. Considering when squared, it shall give you 8. So 8 minus 8 is equal to 0. And then, okay, so that's our 0 for this function. Now let's try the undefined version. So that's 0 minus, 0, let's just set 0 equal to 16 minus x squared. Because that's basically all we need to do for to set it to 0. We don't have to have the power 0.5. So x would be basically equal to 4 or negative 4, considering both of those 1 squared. She'll give you 16, so 16 minus 16 is basically 0. So pretty simple. Okay, so we're done here.